We have been using two methods to help resolve the x and the y of resultant vectors, the parallelogram method and the Pythagorean theorem method. Now comes time for the big guns. What happens if we only have one side of a triangle? How are we going to be able to calculate the rest of the sides of a triangle? If I'm given one bit of information, an angle inside of that triangle, you can figure it out by using trigonometry. There is an acronym known as SOHCAHTOA that helps you remember which trigonometric function you're going to use. We have provided a blue card in the front of your binder. It looks like this. That helps you when it comes time to do trigonometry. I'm also going to be using a special paper called polar paper, and as an introduction I'll show you where to get that. Let's go. In order to find polar paper, we go to my portal page, Laboratory Physics, and once again you will see the homework diary here. But if you go to Shared Documents, we are looking for a document called Two Polar Graphs. The trigonometric method. Now, in our toolkit, we need to have lots of different ways of resolving x and y based on what kind of information we're given. Now, it's fairly easy if we know two sides. We can use Pythagorean's theorem. But what happens if we don't know two sides? What happens if we don't know the two sides of a triangle? Two sides are not known. We can use a tool called the trigonometric method. So here we go. The trigonometric method relies on some properties of right triangles. And we can use those properties to calculate the sides or the vectors of an if we are given the angle. We need to know the angle in order to use the trigonometric method. There are three math functions as part of the trigonometric method. They are sine, cosine, and tangent. To be honest, we don't use tangent that much, but I'll teach you a little bit about it anyway. There's an acronym or an easy way of remembering sine, cosine, and tangent. And it is this, what sounds very much like an American Indian princess. SOHCAHTOA. And basically what we're trying to do is explain that the sine function, the sine of theta, is the opposite over hypotenuse. And you see this funny looking circle here? This is called theta. It is a Greek letter, and basically it represents some angle. You know how in mathematics we use x to represent some number, and we use y to represent some number, and we can even use z to represent some number? Well, angles have their own special symbol, and it's theta. So what this is saying is the sine of the angle equals the length of the opposite side divided by the length of the hypotenuse. On cosine theta is the length of the adjacent side divided by the length of the hypotenuse. And TOA means the angle, the length of the opposite side divided by the length of the adjacent side. Now, you might ask, Mr. Fay, I don't know what the adjacent side or the opposite side means. Well, if we take a look at this triangle here, if I know this angle, and it is 30 degrees, which side is touching this angle? The adjacent side. We call the side that is touching the angle the adjacent side. Which side is across the triangle from the angle that I know? The blue side. We call this the opposite side. And then finally, the longest side of the triangle is always the hypotenuse. Well, I have some information here. I should be ready to solve a problem. Can I use trigonometry to figure out how long the force in the y direction, my blue leg of the triangle, is? Sure I can. So I can, because the blue side is across the triangle from the angle that I know, I'm going to use the sine, which is the opposite, in this case blue, over the hypotenuse, in my case, which is the resultant vector. So, can I replace numbers for letters now? Sine 30 degrees equals, do I know what opposite is? No, so I'm just going to write it again. Opposite divided by, do I know what hypotenuse is? There's actually a number that I can insert, 11.6. Now, I mentioned that I provided a blue card in the front of your binder called the Table of Trigonometric Ratios. Can you get that out? Can you find the angle 30 degrees along the left-hand column? Actually, it's in bold. So, when you found 30 degrees, there are three numbers just to the right of that. The column right next to it is the sine column, if you look at the top. That whole label is called sine. The column next to that is called the cosine column. And then the label next to that is the tangent column. If you put your finger on 30, can you tell me what the sine of 30 degrees is? Can you see that it is 0.500? So I can take this value and replace it with a number 0.500. And that equals the length of the opposite side, which I don't know, I'm trying to find out, divided by the hypotenuse, which is 11.6. How do I get the length of the opposite side all alone? I need to multiply. What am I going to multiply by? Good, 11.6. I want to multiply by 11.6 so that I cancel here. Whatever I do to the right, I have to do to the left. Get out my handy dandy calculators, and this side, if I do the math, I find that it is 5.80 newtons equals the opposite side. Alright, can I solve the red side of the triangle? What is the magnitude of the force in the x direction, my red side? Well, of SO, ka, toa, which element is going to help me? It's not SO, because that deal was opposite sides. It's the cos. Cosine equals adjacent over hypotenuse. Well, in this case, what's my angle? It's cosine of 30 degrees equals, do I know what the adjacent side is? No, so why don't I leave it? Do I know what the hypotenuse is? Sure. I have a number, it's 11.6. In order to figure out what the cosine of 30 is, I simply go back to my Table of Trigonometric Ratios, the blue card in the front of my binder. Can you look up the angle 30 along the left-hand side? And two columns to the right is the cosine column, and so if I wanted a decimal, the decimal of cosine of 30 is 0.8660 equals, do I know what adjacent is? No, that's alright for now. But I do know what the length or the magnitude of the hypotenuse is. That's 11.6. At this point, I say, how do I get adjacent all by itself on the right-hand side? I need to multiply by 11.6. Cancel, cancel. Whatever I do to the right, I have to do to the left. 11.6 times 0.8660. I can use a calculator to calculate that, and I will find that 10.0456 equals the adjacent side, which is the same thing as force in that direction. Now actually, if I respond in Mr. Fay's class, I would write 10.0. Ooh, this is an HP rounding rule, isn't it? the 5 is about to go away. Does it round the 4 up? No, it is even, so I leave it alone. Pretty good. Let's try with some polar paper, which is going to help us do more and more complex things. So let me introduce you to polar paper. It's this bunch of concentric circles, but it also has these lines running through it. And I hope that you see that there is an x-axis and a y-axis. And if you notice, you'll notice that there are 9 little wedges of pi between the x and the y. In reality, do you see a right angle here? And so that means that this little line right here, that represents 10 degrees. And this one represents 20, and 30, 40, 50, 60, 70, 80, and then y is on the 90 degrees. Pretty cool, huh? So let me put some resultant vectors up here, and let's see if we can resolve them by using the trigonometric method. So I have 3 vectors here. 1 is 19.6, pointing in that direction. 1 is 15.61, pointing in that direction. And 1 is 12.1, pointing in that direction. Can I use trigonometry to solve these? Well, first off, could I use the parallelogram method to break this 19.6 vector up into its x and its y? So if I were to do that, I would draw a vector in this direction to represent the x, and I would represent a vector in this direction to represent the y, but you know what? I'm going to move it over here. Hey, is there a triangle there? In fact, is there a right triangle there? Can I move this triangle out to here to make it easier for us to see? So if I take a look, I have one side of a triangle, and I know that that is 19.6 newtons. I have the x-ness of that triangle, but I don't know its magnitude. And I have the y-ness of the triangle, and I don't know its magnitude either, but I do know that they form a right triangle. Is there anything else that I know about this triangle? Like, for example, using the polar paper, can I figure out what this angle is? If you look, does that tell me what angle I have? Sure, it's a 40-degree angle. And now, let's remember our Indian princess. So, ka, toa. All right. So, in order to figure out, let's say that we want to know what is the force in this direction. Which side of our triangle do we have? Do we have the opposite side or the adjacent side? The red side is the adjacent side. It is the side that is touching the angle that I know. If that's the case, which one of these am I going to use? The so, the ka, or the toa? I hope you identified that we can use cosine in order to calculate force in the x-axis. So I'm going to write my formula is cosine of theta equals the adjacent side divided by the hypotenuse. Now I'm going to replace numbers for letters, or in this case symbols. Cosine, what is the angle we're talking about? 40 degrees equals, do I know what the adjacent side is? No, but that's alright. I'll just write adjacent. Do I know what the hypotenuse is? Yeah, it's actually labeled for me. It is 19.6 newtons. In order to figure out the decimal for cosine of 40, I go to my table of trigonometric ratios, look up 40 along the left-hand side, and find the cosine to be 0.7660 equals. I don't know what the adjacent side is. I'm trying to find it. And divided by 19.6. How do I get adjacent all by itself on the right-hand side? I multiply by 19.6. Cancel, cancel. And I multiply the left-hand side by 19.6. If I use a calculator, I can calculate this to be 15.0136 equals the adjacent side, which is also known as force in that direction. Now, if I respond in Mr. Fay's class, I call that 15.01 newtons. Cool. Could I figure out what the blue side is? So, what is the force in that direction? Now, the blue side is the side opposite the angle that we know, right? So we are looking for the opposite side. Which part of SOHCAHTOA am I going to be using? If you recognize that the SO deals with opposite, you'd be right. So I'm going to take the sine of theta equals opposite over hypotenuse. The sine of 40 equals, do I know what the opposite is? I don't, so I'm just simply going to write it again. Divided by, do I know what hypotenuse is? I do, it's 19.6. Now, if I look on my blue card, I see that the sine of 40 is 0.6428, and that equals opposite divided by 19.6. How do I get opposite all by itself? I multiply by 19.6. Cancel, cancel. Whatever I do to the right, I have to do to the left. I can use my calculator to calculate this value to be 12.59888 equals opposite, which is also known as the force in that direction. And if I respond in Mr. Fay's class, it would be 12.60 newtons.